Hello. Today we're going to talk about practical electrical grounding, especially as it applies to the power supplies and instruments you're going to be using in Grad Lab and Senior Lab. So, as you know, when we measure a voltage in an electrical circuit, we have to measure it between two conductors. We can generate a voltage by hooking up a battery, which has its minus terminal and its plus terminal, and say hooking those up to a resistor or maybe a switch and then maybe a light bulb or something like that that's useful to us. And we can make current flow around this loop, that kind of thing. We can measure voltage differences between two conductors, say across the lamp here. We might measure a voltage, but there's no absolute meaning of 0 volts except as we define it. So often we will say something like, oh, this bottom wire right here, that's going to be 0 volts. Okay. But before we go and we talk about what 0 volts means in our circuits and how we set things up reasonably with the instruments that we're going to be using, let's step back for a second and talk about household wiring, because we usually use instruments and power supplies that are plugged into the wall outlet in the lab. Now, the wall outlet in the lab looks like this, of course, and it's got 3 connectors for each place you can plug something in. The 3 connectors are the hot terminal, which is the small one right here, and the neutral terminal, okay, which is the larger of the 2 flat connectors, and the ground or safety ground, I should say, or third prong, which is the funny shaped one at the bottom. Okay. Now, the way we use these is that we send this off to some switch, okay, that might be on the wall or on your instrument, and then some useful thing, like I said before, with a lamp, okay, where the current flows from the hot to the device, back through the neutral to this point on the plug. Now, what's hooked up on the other side of the plug is that the power company acts as a big sine wave generator that can supply 120 volts AC at 60 hertz in the US, and they send that to us in your house or in the lab, and coming in on 2 wires. Practically speaking, though, one of those wires is chosen to be the neutral wire, or is grounded, driven into a copper pipe that is or a copper stake in the ground, or your water pipe sometimes, that kind of thing. And this, as I just said, this one is run to the neutral, okay, and this one is run to the hot. So now we have an asymmetry between them because one of those wires is now connected to earth somewhere, literally to a stake in the ground or a water pipe that's buried underground or something like that. The ground wire is special in that no current should ever flow through the ground wire to turn on that lamp. That ground wire is brought back and connected also to this point, to the where the ground stake is driven into the ground. So the ground wire comes out and kind of connects to whatever housing is around all this stuff in your lamp. Okay? And because it's connected to the housing, that sort of prevents the user from accidentally touching the hot terminal or the neutral terminal, and if one of those shorts to the ground wire, that can be detected and shut off the circuit. So this ground wire also, because it should be carrying no current, means that the potential is whatever it is at this point in the outlet, at this point in the lamp, at this point in the water pipe. There is no current flowing, which means that the voltage drop across the ground wire equals current times the resistance of that wire should be 0. In contrast to the voltage drop across the neutral wire here, which actually is carrying current. A bunch of current is flowing along this neutral wire, so therefore whatever the current is, times the resistance of that wire, has some voltage drop across the neutral wire, which equals I times R. And that might work out to be a couple volts or something if you have a bunch of current flowing, or if you have a little bit of resistance in that wire. So this third wire turns out to be very important for most of our grounding schemes in laboratory instrumentation. Before we go on and talk about how to hook up our laboratory power supplies, let's talk about the different things we might do with batteries in a circuit. So here's a battery, and as I said before, we could hook this up to a switch and a light bulb or something like that, but we might want to define our voltages in different ways. Okay, so let's say that we have that switch and we have that light bulb, okay, and we could draw this circuit by connecting the light bulb back to the battery like this, but when we have ground definitions, a definition of 0 volts, we could also draw it like this, which intrinsically says that this really means that those are connected and that we're considering in our circuit for this line right here to be at 0 volts. By the way, I could draw this, this thing over here, the ground symbol, differently. I could use 3 lines like that. That's a very common one. I like to use the triangle just because it's nice and quick. So either way, we're just saying, hey, that wire is hooked up to whatever it is I'm going to call 0 volts. And what that really means is that I have some big chunk of metal or some piece of my experiment that's conductive, or the ground itself, and I'm just going to say that whole thing sits at 1 potential, and it's going to be called 0 volts. Okay? So that's what we mean when we have these symbols and when we don't connect them. All right, so let me erase the connection line and the 0 volts there. That now means that both of those are connected volts, and if I throw the switch right there, then the current is going to flow from the battery through the lamp and back along the ground, okay, completing the circuit. Now, in the way I've drawn this right now, I could say that the 0 volts is at the bottom of the battery, and maybe there's plus 5 volts or something like that up by the switch. Or I could actually change my definition of the ground and erase these symbols right here, like this, connect those up, and I could say, oops, I want to use red here, so or black here, so I'm going to connect those up, and I could say that this was 0 volts. Okay, so there's my ground symbol right there, and that would mean that this is at minus VBAT down here, okay, and 0 volts up here. The circuit's going to work exactly the same way still, right? The current's going to flow the same direction, all that kind of stuff. I've just redefined where is 0 volts. Now, I could also hook another battery up to this. Okay, I put its minus terminal on the top, plus terminal on the bottom. Sort of same orientation that I did these, except for now I've got the minus terminal of this battery hooked up to where I've called ground. The first battery has its plus terminal hooked up to where I've called ground. So now, if I have, another switch, okay, and a resistor or something like that, we could hook those together. Who knows what's going to happen, okay? But the point is that at the top here, I would have plus V battery, or the second battery, or something like that. I'd have minus at the bottom, plus at the top, and 0 volts between. Just because I've hooked the batteries up sort of opposite each other. I may or may not have actually hooked this 0 volts to earth. Instead of using batteries, in the lab we usually use power supplies. So this is an example of a power supply that has 3 places that you can set the voltage that it's going to provide to your circuit. Well, you'll notice that the left 2 parts of the supply have 3 terminals, black, green, and red. Black, green, and red. And whereas the right-hand one only has 2 terminals, black and red. This one right here is effectively like a battery. You should think of it as a battery. In fact, I'm going to draw in for each of these that there's a battery, and in this case, the battery has its negative terminal towards black and the positive one towards red. And that's the true thing in all 3 of these. Okay, so this is how you should think of that. Power supply, of course, it's an adjustable voltage. You can do fancy things like set current limits and things like that. So we can hook these batteries up like I did in the previous circuit, where we could connect them differently. We could connect, as in that previous example, we can connect the positive side of one battery to the negative side of another, And if we wanted to call this 0 volts, then this would be negative V1, and this would be plus V2. Okay, and we could use this one, the third one, as another supply, some other voltage that we wanted to have. Okay, so we could connect its negative side up to 0 volts, and then we could have this be plus V3. Okay, so we could supply 3 voltages to whatever circuit it was that we wanted to operate. So now the question is, what the heck are those green wires? The green wires are hooked up to the chassis of this power supply. So we should think of those as being connected to the metal frame of the power supply. The metal frame of the power supply is also hooked up in a special way to the ground of the outlet that the power supply is connected to. So you remember that safety ground, right, that goes all the way back over to the water pipe where the utility company hooks into the panel at the side of our house or our building. Well, there's that ground, that safety ground right there is connected to the chassis of the power supply. So I can choose if I want to. I don't have to, but if I want to, I can connect that safety ground up to 0 volts in my circuit. Okay. I could possibly hook it up somewhere else, but that's not a choice you would usually want to make. So this is a pretty normal configuration that we'll use here, where we take one of the green terminals and we hook it up to whatever we're calling 0 volts in our circuit, and we use the various other parts of the supply to supply voltages relative to 0 volts. We don't need to hook up the other ground to there because these two really are just hooked together. Okay, the 2 green terminals are going to the same place. They're both hooked up to the chassis right there. So you needn't do explicit connections of those things. Now, if you use multiple instruments like oscilloscopes and function generators and power supplies, you need to know that the green prongs or the chassis on all of them are plugged into that third prong on the outlet, and you should plug them in hopefully to the same circuit so that they're all using the same safety ground to go back to the edge of your building. Okay. Now, in some cases, our instruments will have coax connectors rather than banana plugs like that power supply did. The coax connectors have 2 metal connections on them. Okay, there's the outer one right here, right? And there is the inner connector that's the very small dot right in the center there. Okay. You need to be aware that that's, again, it's 2 pieces of metal. We measure voltages with our oscilloscope with 2 pieces of metal. If we want to produce waveforms with a function generator, we generate those voltages between 2 pieces of metal. Here they are, the outer and the inner part of the BNC. The complication here is that in many devices, in fact, I'd say most devices that have BNC outputs, this part of the BNC, the outer connector, is actually attached to the chassis ground of this instrument. In other words, it is connected to the third prong. It is connected to the safety ground. So that means that you can't float this input to the scope. You cannot apply a negative voltage to right here. You need to always connect that outer shell of the BNC in a grounded instrument to the ground of your circuit. You cannot go to some random place in your circuit, say, here's a few resistors, okay, bunch of resistors, right? You cannot go, and if this is connected to the safety ground of the power supply, you cannot go with your oscilloscope and measure this voltage right here, okay, with these 2 pieces of this, the BNC. Now, there are some cases where you can get away with this. If your scope is battery powered, or if you floated your whole circuit or something like that. But in general, you better think hard before you want to try and do something like that. So I think that covers grounding for us. We know that we have to consider where is 0 volts very explicitly. We need to think of our power supplies as batteries. We need to hook the correct positive or negative terminal of each battery up to 0 volts in a sensible way. And we need to be careful when we start using oscilloscopes and function generators and things that may have a grounded terminal as one of their two conductors of their output or input. And with that, I think that you're ready to go and think about plugging things together in the lab. So good luck.